Are you interested in pushing your project gallery to the next level? Then you gotta check out this animation. Very often we want to show an image when hovering a project. It's a classic animation that I see everywhere, but I very much often less see this type of animation because it requires 3D and a shader. And that's why I think it's super interesting to take a look at this animation right now. I'm gonna try to remake this using React 3 Fiber, and Framer Motion. And as always, you can find the live demo and the source code in the description. Alright, so what I have here is a really basic Next.js application, and I have a list of projects, and we can see in the code it looks something like this. Here I have a smooth scroll initialized, and then I have some spacers just so that I can scroll here, and then I have my list of projects, and this is just some basic HTML and CSS. And actually I'm going to put all of that on the side for now, and we're going to go straight into 3D. So I'm going to comment that, and we can start right away by creating a canvas using React 3 Fiber. So for that, what I'm gonna do is start by creating another component. I'm gonna call it the scene, and it's inside of that scene that I'm gonna create my canvas. And then instead of having a div here, what I'm gonna have is a canvas, and that canvas here comes from React 3 Fiber. And then inside of the canvas, that's where I'm gonna put all of my 3D elements. And for that, I'm gonna create another component, and I'm gonna call it the model. And so I'm gonna go out here in the components and create the model component. And it's gonna be a React component, but now it's gonna be inside of the WebGL context because it's inside the canvas. So the div here doesn't make sense. So instead, I'm gonna return a group. And then one last thing, if I want my canvas to take the full screen, I need to put it a div as a parent, and the canvas will always resize itself to take the full width of its parent. And so here I'm just gonna put the canvas inside of a div here, and I'm gonna do class relative, and I'm gonna give it a height of 100 viewport height like this by doing hScreen. And with that, I should have a canvas that takes the full height and full width of my window. And now I'll go back inside of the model, and here I'm gonna create my first mesh. I'm gonna create a plane, and that's where the image will be. And then I'll just have to move it on mouse move. So to do that, I'm gonna create a mesh, and actually I'm just going to delete the group here, and I'm just going to create a mesh. And the mesh now requires two things. One is the geometry, and another thing is a material. So for the geometry, I'm going to give it a plane geometry because I just need a 2D plane for an image. And now that plane geometry requires a couple of arguments, and if we take a look at them, we can see it requires a width, a height, width segments, and height segments. So for the width, I'm going to give it 1, for the height 1 as well. And then the width and height segments is basically the topology of our geometry. So how much detail do we want it? And I'm just gonna do 15 by 15 for now. And you'll see I'll put the wireframes to true, and you'll see exactly what those values are. And then for the material, for now, I'll just do a mesh basic material, and I'll do color red just so that we see what's going on. And I'm gonna save that. And now I'm gonna go back inside of the page.js, and here I'm just gonna import my scene, and I'll save that. And here is my rectangle, and I'm just gonna change the arguments here just to make the square a bit bigger for you guys. And then you'll see if I put wireframe to true to the material, now we can see the topology of the 3D geometry. And if I boost the amount of segments here, you'll see that it's getting more detailed, and that matters if we want to start creating like an animation, like a wave animation or something like that. Then we want to have like enough segments. If we don't have enough segments, it's going to be like all choppy and like blocky, right? But I think 15 by 15 is good for now. And then just for now, I'll reduce here the width and the height segment. And with that shape now, I can start moving the geometry around. That's the basic of this animation. And to move that 3D object around, what I've created here is a use mouse hook, which is basically a hook that gives us the position of the mouse. But instead of using a state, which is what you normally have inside of a hook, here I'm using motion values. And the reason why I'm doing this is it's because the performance is going to be better that way. And the reason why is if I have a state here, and every time I move my mouse, I set the state, then that means that my component, the one that I will be importing the use mouse hook, that component, every time I move my mouse, is going to get re-rendered every time I move my mouse, which is a bit crazy on the performance. It's not the best, but it would still be doable. In some cases, it's fine. But if I can optimize it, I'll optimize it. And so that's why I use motion values here instead of using a state. And so I can go back inside of my model. And if I want to use that use mouse hook, what I'm going to do is just do a const mouse is equal to the use mouse hook that I've just created here. And as you can see here, the mouse returns us an X and a Y value, which are motion values. And so I can use them directly to my mesh here by adding a motion tag in front of it. And if I want to move my mesh around, I could do position X like this is equal to mouse.x, and position Y is equal to mouse.y. And you'll see I'm going to save that, and this should not work And here I have an error. I just need to import the motion here from Framer Motion. And also it's important here to specify that the motion tag comes from Framer Motion 3D, not just the Framer Motion normal package. If we want it to work on mesh and 3D objects, we need to use the Framer Motion 3D. And so if I use here my mouse on the position X and position Y, you're gonna see that as soon as I'm gonna move my mouse, it should not work. Like you're gonna see that my plane is just disappearing. And the reason why is because here, the mesh, I'm giving it a position in pixels, right? The position that comes from the use mouse hook here is coming from the client X and client Y, which are values in pixels. And I'm basically giving a value in pixel here as the position X and Y for the mesh, which doesn't make sense, unfortunately, because 3GS works in a Cartesian coordinate system and not in a pixel coordinate system. And so what that means is if we take a look at a coordinate system in like a Cartesian one, that's basically how it is. It's in numbers, and so it goes -1, -2 on the left, 0, 1, etc. And so if I give it like a position of like 500, the plane is just gonna fly right off because that number is way too big. It's not adapted, right, to that coordinate system. And so what I need to do right now is convert those pixel values into Cartesian values, if you will. And so what I'm going to use is the use transform hook from Framer Motion, but you could use something like the math.map function as well, which basically what it's going to do is map a set value, like a range of values, into a new range of other values. So we're going to give it a range of pixel values, and it's going to transfer or convert it into a range of Cartesian values. So what it looks like is, for example, I could have a next value here, which would be equal to the use transform hook. And now which value do I want to transform? It's going to be the mouse.x value. And now here I need to give the range. And so all the possible values that this mouse.x value can take. And so I need to know the width of my window for that. It's going to be basically 0 and window.inner width, right? Those are basically all the values that this mouse.x can take, because this mouse.x here is basically the client x, right? So the client x can only be a value between 0 and the width of the window. But I can't use the window here because I'm in Next.js. If you're not in Next.js, then you can just do window.inner width, but I'm in Next.js, so I need to use a hook for that. And that's basically what I've created here. Another hook similar to the use mouse hook, but this time it's the use dimension hook, and it returns us the dimension of the window. So I'm gonna go inside of my model here, and I can do const dimension is equal to the use dimension hook. And here I can do dimension.width. And then I need to specify what are the transformed values going to be, right? This is the in range of values, and I need to specify the out range of values. And that's going to be some values in Cartesian, in like a Cartesian coordinate system. And so for that, I need to know the width and the height of the viewport in Cartesian or like in the 3GS context. And so for that, I just need to do const viewport, and that's going to be equal to the use 3 hook here. And that, if I console it, you'll see here that my viewport has a width of 4.8 and a height of 7.6. And that's in Cartesian, right? It's in the 3GS context. And so if I apply the width here to that, then I understand that the range, the minimum range of value that it can take is the width divided by 2 multiplied by -1, right? And then the last range is the width divided by 2. I hope that makes sense. And so that's what I'm going to do here. I'm going to uncomment that. And so here it's going to be -1 multiplied by the viewport.width divided by 2. And so that's the smallest value that I can have on the x-axis. And then the biggest value is just going to be the viewport.width divided by 2. And for now, we can just start with this one. I'm just going to give it the x here for the position.x. And on the y, I'm just going to do 0. And you can take a look if that even works. And here you can see on the y, nothing is happening because I have a fixed value of 0. But on the x, we can see that it's now moving perfectly with my mouse. And so I'm just going to do the same thing, but for the y-axis. And so here it's y, and I'm basically converting the pixels value of the mouse. And so it's going to be 0 dimension.height. And then here it's going to change, because if we take a look at the Cartesian system, the y-axis is positive at the top and negative at the bottom. And so it's going to be viewport.height divided by 2, and then -1 multiplied by viewport.height like this. And then I can take my Y and give it here, save that. And with that, I am now moving my rectangle while I'm moving my mouse. So that's really nice. And if I resize, it should also be working. So yeah, that's pretty good. And that's pretty nice. Honestly, if we look at the amount of code that it took us to do this, it's not a lot. And this use mouse thing and this use dimension thing are very basic stuff. If you do enough React, you're gonna see that we reuse those functions all the time. And so don't worry too much about those hooks. And now, if I look at this, the thing that I don't like about it is that it's just straight up linked to the mouse, right? I would like to create some sort of easing, right? I would like to be a bit more smooth. Like right now, it's like super linked to my mouse. It's like very functional, but not very, like the feeling is not nice, you know? So to smooth my mouse, what I'm gonna do is I'm gonna have to use the request animation frame, and I can tap inside of the request animation loop of Three.js. And for that, I can just do use frame. Instead of creating a new request animation frame loop, I can simply go inside the one that's already running for Three.js, right? So I'm gonna have the use frame here, and that's a function that looks like this. And if I log this, you're gonna see, if I do LOL, you're gonna see that this is running at every single frame, right? And so now I'm gonna create a smooth mouse. Instead of having this like directly linked with the cursor, I'm just gonna move this near the return function because those are related. And then what I'm gonna have here is a smooth mouse, and that's gonna be an object here. And I'm gonna do this very similar thing as the use mouse. I'm gonna do an X and Y value here, which are motion values. That way the performance is better. And then at every single frame, I can extract the X and Y value from the mouse. And then what I need to do here is basically interpolate some value towards the mouse to create this smooth animation. And for that, I'm gonna use the linear interpolation. I've used it in some of my videos. And so this is what I'm gonna use here, the linear interpolation. And that's basically a mathematical equation that allows me to bring a value closer to another one by a certain percentage. So I'm just gonna copy that equation here and I'm gonna paste it here. And then as you can see, I have an example here. If you give a certain value, for example, 10 inside of the lerp, and you want to interpolate it towards another value, for example, 0. So you want to bring 10 closer to 0 by 10% here, then the returned value here is going to be 9. That's basically the linear interpolation. And so we can use that concept to create a smooth mouse. And so for that, I'm going to set the values of my smooth mouse. So I'm going to start with the X and I'm going to do set, and I'm going to just use its current value. And so I need to do get like this. And now I'm going to interpolate it towards another value. And that value is going to be the current value of the mouse on the x-axis. And I'm going to bring that smooth mouse x value closer to the real position of the mouse by something like 5%. And so at every single frame, and it's that lerp function here that I need to use. And so what that means is now at every single frame, I'm bringing my smooth mouse closer to the position of the real mouse by 5%, right? I'm going to do the same thing, but for the y-axis. So here, mouse.y.set, I'm going to grab its current value and move it towards the real value of the mouse. And now here in my position.x and position.y, instead of using here the mouse.x and mouse.y, I'm going to use my smooth mouse instead. And I'm going to save that and see if that works. And now I have an error. I need to import the use motion value here, and that comes from Framer motion. I'm going to save that. Okay, this is not working. I need to do a get here for the value of the real mouse because it's also a motion value and not a simple number. So I need to do get. So I'm going to save that. And now if we try this, I now have a nice kind of a lerp. When I move my mouse, it's not directly linked, right, with the mouse. And this looks much smoother. And to be honest, it's a bit too smooth for me. So I'm going to change here the value of my interpolation, and I'm going to do maybe 0.1. And so the lerp is going to be a bit less intense. I'm going to save that. And yeah, with that, we have something like this. And to me, that looks a bit better. And also here, I'm using a lerp. So it's linear, but you could add any other function to have a different easing for like the movements of the plane here. If you want to create like your own easing, you could do that as well. Okay, and now that I'm able to move my plane around, I can now start deforming it based on its movement. as you can see in the demo here, you're going to see that the faster I move my mouse, the more distortion there is to the plane, right? And so that's basically the distance between my real mouse and the position of the plane, and that's why I moved it beforehand before doing the distortion, right? So now I'm going to do the distortion, and for that we need to use a custom shader. So to do that, I'm just going to start really simple and create a shader that's going to replicate exactly what I have right now. So a really basic shader. So for that, instead of using a mesh basic material, what I'm going to use is a shader material. And now that shader material requires a couple of things. The first thing is a fragment shader, and another thing is a vertex shader. And so that's basically how it looks like. I have a vertex shader that simply returns our geometry here as is, no modifications. And then I have a fragment shader that returns us a certain color, and that's like RGBA for the red color. And if I save that and I go in my model, go back inside of my fragment and vertex shader, and here I'm just gonna import them. So here I'm gonna do fragment and I'm gonna do vertex, and those are basically imported from that file. And so I'm gonna save that, and here we should have our basic geometry that we had before with a red color. And you're gonna see if I do wireframe true, we should be back to what we had before, but this time we now have a nice shader material instead. And with that, we can have full control over the texture and the geometry of our mesh. So that's really nice. And now I'm kind of tired of seeing this rectangle, so I'm gonna start adding an image on top of it. That's the first thing that I'm gonna do. So if I want to add an image to it, I need to load a texture. And so I have all of my images here inside of the public folder, images here folder. And so I'm gonna grab the first image and extract it and create a texture. So I'm gonna have const texture, and that's gonna be equal to the use texture from React 3 Dre. And then I can simply give it an input, and that's gonna be my images. And then I'm gonna choose the first one. And then I need to find a way to pass that texture into the fragment shader. And to do that, I need to use uniforms. So I'm just gonna create a const uniforms, and that's gonna be equal to the use ref hook. And here I'm gonna have my first uniform, and it's gonna be the U texture. And that's gonna be a certain value, and the value is gonna be the texture, simple as that. And now I need to give that uniform object to my shader material. So I do uniforms is equal to uniforms.current, because it's a ref, right? So current. And with that, I'm gonna save it, and I'm gonna go inside of my fragment shader here inside of the shader function. And so now the first thing that I need to apply a texture are my UVs, and my UVs come from the vertex shader. And so for that, I'm just gonna create a varying variables. That's basically a variable that's shared between the vertex and the fragment. So it's gonna be a varying vec2, because it's a vector 2, right? UVs stand for X and Y. So here I'm gonna have VUVs, and those VUVs are equal to my UVs here. And as you can see, we have a lot of variables here like UV, projection matrix, model view matrix, and position. They're not declared, but still understood by GLSL. So don't worry too much about that. You can read online if you're interested. And so once I have that, now I can go inside of my fragment, and I have my VUVs here, and I can use them to apply the texture. And as well as my varying, I also have here inside of my uniforms, I have my U texture, right? So here I can have my uniform, and now it's not gonna be a vec2, it's gonna be a sampler 2D, and that's my U texture. And then here I can create a vec4 texture, and I can create a new texture 2D. And actually, this is not capitalized. And here it requires my texture and then my VUVs like this. And then instead of returning some colors here, I'm gonna return my texture. I'm gonna save that. And we should have something like this. And I see the image, but the wireframe is still set to true. So here I'm just gonna toggle the wireframe off. And with that, we should have a nice image. And I'm gonna switch the image now just to have a nicer one. I'm just gonna do 2. And that's pretty good. Now that we have the texture, now all we have to do is deform the plane, and that's the fun part. And like I said, the faster we go, the more distortion or the more of a curve we want to have, right? And this speed of the plane is essentially the delta or the offset or the difference, you choose the term that you want to use, between the current position of my pointer and the position of my plane, right? The distance between the two, the bigger it is, the faster my mouse is moving. That's kind of what's happening here. So that's what I'm going to do here. I'm going to create a U offset uniform that I'm going to be able to pass to the fragment shader to modify the geometry of the plane, right? So I'm going to do U offset, and that's going to be a value, and it's going to be an object with an X value and a Y value, right? There's going to be an offset. Actually, I'm going to call it the delta. It's a bit more clear to me, the delta being the difference between two positions. And now I'm going to set that delta at every single frame. So I'm going to do some refactoring here. I'm going to do const smooth X, and that's going to be equal to that value here because I'm going to reuse it. So might as well put it inside of a variable. I'm going to do the same thing, but for the Y axis. So smooth Y, and I'm going to use that. And then I can set my delta, and to target the uniforms here, I'm not going to do uniforms.current. I have to target the mesh. And so here I need to add a ref to the mesh. I'm going to call it the mesh here. I'm going to create a const mesh is equal to a ref. And now I can change the uniforms here. So I'm going to do mesh.current, and it's inside of the material. And here I can find the uniforms, and I can find the U delta, and I can find the value, and I can set it here this way, and I can do X is going to be equal to something and Y is going to be equal to something, right? And the delta is the difference, like I said, and it's going to be very easy. We have everything we need to do that, and we can simply do X minus the smooth X, and it's X.get because it's a motion value. And on the Y, I'm going to do the same thing. And so with that, I have access to my delta inside of my shader. So I'm going to go back inside of it, and we're going to start playing with the vertex shader. And it's this guy that will basically create the curve. So to create the curve, we need to truly understand the sine function. Okay, if you don't understand the sine function, you're going to be completely lost at what I'm going to do right now. And it's quite normal. I was very lost at the beginning too. It's a bit complicated compared to normal like web development. All you have to know about this sine function, okay, to make it very simple, is forget about everything but this part. Like, this is the only part that's important. So just know that this screenshot comes from this graph, all right? But for now, we can abstract that and just think in that term for now. And as you can see, this is a curve, and that's kind of a curve that you can imagine that could be on the sides of the plane, right? That's kind of the curve that we can create. So we're just gonna recreate that basically, but inside of our shader. As you can see, the first thing that I need is here you can see that it's a value between 0 and pi, right? So pi, and here it's 0. So I'm gonna need my pi value, and I can just paste it like this. I just took it from the internet. That's basically the pi value, and I can now use it to create this curve. And then let's see what we can do, right? I'm gonna create a new object, a vector3 new position, and that's gonna be equal to the position. And now I can use this guy here instead of the position. I'm going to use the new position, and this new position, I'm going to start modifying it. So I'm going to start with the x-axis. I'm going to do new position.x, and I'm going to modify it. I'm going to do plus equal, and I'm going to do the sine function. So I'm going to call this function right here. And we know this is a value between 0 and pi. So how do we represent that inside of our x-axis? Well, we can use the UVs, which are values between 0 and 1, so uvs.x, and we can multiply that by pi. And so now our first UVs are 0, so we're going to be here, multiplied by pi is going to be 0. And then the last UVs are going to be 1, and so we're going to be right here, multiplied by pi is the end of the curve, right? And since we're on the x-axis, we don't want to use the UVs on the x, we want to use the UVs on the y. And I'm just going to save that and see what we have with that. And we should have something like this. And as you can see, I'm just going to take a screenshot so that I can show you what's happening here. And now the reason why I used the UVs on the y-axis is because this right here is the y-axis, right? It's not the x-axis. And so then if we want to create the curve upstairs, then we're going to do the same thing, but I'm going to copy paste that. But for the y values, we're going to use the x UVs. So I'm going to save that. And now we have something that looks a bit crazy. I'm going to remove the x for now. And as you can see here, we have the curve for the top part of the plane, right? But obviously it looks a bit bad. It's just always like fixed like this. And we want to increase or decrease the curve based on the offset, right? So that's where the offset's going to come in. I'm going to comment that for now. And that's where our uniform, I'm going to copy paste that here. And it's going to be uniform U offset, and it's a vector 2. And I can start using this offset here inside of my sign. So now the offset can be a value between 0 and X, right? It could be 5, it could be 10. So we can simply use the offset very simple like this, offset.x, like this. So sometimes it's going to be 0. If it's 0, it means the plane is not moving. And so we're just going to plus equal 0. And so we're going to have no curve. And then the bigger the offset, the bigger the curve, right? So I'm just going to do multiplied by 0 like this. And I need to do 0 point. And as you can see, no curve. And now let's say my offset is 0.5, a bit of a curve. Let's say my offset is even bigger, maybe it's 1, then more of a curve, and it goes like this. Let's say it's 5, then it's a crazy curve, right? So that's why I'm using my u offset.x value here. And I'm going to save that, and let's see what we have. I'm going to move, and let's see what we have. I'm going to move here, and nothing is happening. And I believe there's probably a problem with my offset value here. I need to check it. Oh yeah, it's not offset, it's delta. So here it's u delta, not u offset. Sorry about the confusion. I'm going to save that, and this should work. And yeah, this is working, but as you can see, like the value is very, very high, right? So it's getting crazy very fast, but the concept is here. So what I'm simply going to do is add a modifier to reduce the intensity, and I can do like 0.001 just to like really reduce the intensity. And I reduced it by too much, so maybe something like that. And with that, we have a nice wobble, as you can see, right? This looks pretty good. And I think it's still a bit too much, so I'm going to reduce it and do like this. I think that's the right value. And that's like enough of a curve for me. And now I'm going to do this, but on the other side for the y-axis. I have my curve on the x, but I want my curve for the other axis, right? So I'm going to do the same thing, but here I'm going to modify. Oh, I had it here, so I'm just going to modify my y-axis. But I'm taking the UVs on the x-axis, the U delta on the y-axis, and I'm just going to save that and see what we have. And we have something like this. However, I feel like on the x, it looks good, but on the y, it's reversed, right? It's not going in the right side, right? So I'm just going to change that. And here I'm just going to do -1 to like change the direction, add some parentheses here. And now this makes much more sense. I'm going to put this a bit bigger. And yeah, this is looking pretty good. And I could change this value here if I want it to be a bit more intense. And that's even more of a wobble. And now there are two more things that I want to see. The first thing is we probably don't see it, but I'm guessing that the image is stretched a bit. It's probably not looking like the original one. And the reason is I've just slapped a texture on top of a plane that has a certain aspect ratio of 2:3. But my image here, I don't think it has a ratio of 2:3, right? We would need to do the math here, but I'm pretty sure that it's getting stretched. Like the plane is too thin. Like the image, we don't really see it, but I think it's getting stretched. For example, if you would use a portrait, you would have like the face of the guy would be deformed, right? Or the face of the girl, it would be deformed. So if we want to have like the perfect dimensions of our plane according to the image, what we can do very simply is use a hook by React 3 Dre. And that hook here, I'm going to have a scale, and that's going to be equal to the use aspect hook. And here I need to give it a couple of parameters, the width, the height, and a certain factor. If I give it a factor 1, it's going to be full screen. So what's going to be the width and the height? Well, it's going to be the texture dot image dot height, or the width, I mean, for the first value, and then texture dot image dot height. And if I give it 1, you're going to see that that's going to be full screen. And now I can use this scale and apply it to the mesh. So here, the geometry is just going to be 1 by 1. But instead, here I'm going to add a scale equal to the scale that was returned by my use aspect hook here. So I'm going to save that. And yeah, here you can see that it's full screen. And if I move my mouse, I have my distortion, but obviously it's like way too big. So I'm just going to reduce that and maybe do 0.225. So reduce the factor. And now I have something like this. And as you can see, the image now is like the right dimension, right? And now since I've scaled everything, the values are a bit different. So I'm just going to go ahead and reduce inside of my shader the strength here. And I'm just going to reduce that by 2 just so that it's a bit less intense. And that looks pretty good to me. So yeah, with that, we have a nice plane that gets deformed as we move the mouse. But I want to add one last thing, and that would be kind of the real case scenario, what we would have inside of our portfolio. Something like this. As you can see, the image is changing as I'm hovering on a different project. And that's a bit of a more realistic scenario. And also, if I move my mouse outside, it's fading out. So I want to take a look at those two things. So to do that, I'm going to go back inside of my page.js, and I'm going to toggle back everything here, and I'm going to save that. And now this should be a bit weird. Now I would have my projects here, my spacer here, and then my canvas, right? So this doesn't really work anymore. And to fix that, all I'm going to do is put my scene here in position fixed, and I'm going to do top 0. And if I save that, I should have something like this, but now my canvas is not taking the full screen. So I'm going to do H screen and width full. And now I should have something like this. And if I scroll, you're going to see that my canvas is staying in place, and this creates like this nice effect. And so now we need to track which project we're hovering. And then with that, we go back into some basic React. We leave the 3D aside for now. And for that, I'm just going to close my use effect. This is for the smooth scroll, so don't worry about that. Closing that, and I'm going to have here a const. I'm going to have active project, and here a set active project, and that's going to be a state. So use state, and I'm going to have it at null at first. So no projects are active at first. So meaning no projects are hovered, right? And I'm going to pass my set active to my project here, and I'm going to go back into my projects. And now I have access to the function as a prop, and I can use it to toggle if a project is active or not. So the first thing that I want to do, if I hover into one of my projects, I want to activate it, right? So inside of my LE, that's where I have my project. I'm going to do on mouse over, and here I'm just going to do set active project, and I'm going to use the index that's returned inside of the map function here. And I'm going to copy paste that. And now if I leave the main container, the main list here, so the UL, I'm going to set the active project to null. So no active there are currently no active projects, right? And I can then pass that value to my scene, active project here. Go inside of my scene, it has the active project as a prop. I'm going to prop drill it to the model, and now the model has access to the active project, and that's basically an index. It's a number, right? And so I can basically use it to change the texture here. But how do I do that? Right now, I've only loaded one texture, so I need to load all of them. So for that, what I'm going to do to map all of my projects here, I've used an array of data, which is like hard coded for now. So I'm just going to import that projects inside of the model here. And so I could have const textures is equal to those projects, which is an array. It's a JSON, right? And so I can map it and have access to the project in the index. And here I can do use texture of my project.source. And with that, I have an array of textures. And here I don't need the index actually. And I can make this even cleaner like this. And then here for the scale, this won't make sense anymore. I have textured, it doesn't exist anymore. And hopefully all of my images here have all the same aspect ratio. They're all the same size. So I'm just going to do textures, and I'm just going to grab the first one, right? Because it doesn't really matter. It could be anyone. They all have the same aspect ratio, the same scale, right? And then here initially in my uniform, so in my shader, I'm also going to give it the first textures for now, because it won't matter because it's going to be invisible, right? So I'm just going to do that for now. And this, if I save that, I should have something like this back with the first image. That's probably the image associated with Richard Gaston, right? So, and now obviously if I hover, even though the active project is getting toggled, it's changing, the state is changing, my image here is not changing. And the reason is I need to actually do that manually. And for that, I can have a use effect, and that use effect can listen every time that active project, which is my value here, every time it changes. Then I'm going to grab the code similar to that, and I'm going to set the value of my U texture, right, which is uniform value here. And I'm going to set it to the textures of the active project, something like that. And hopefully this will work. So if I leave it at that, nothing is happening. And I think that's because sometimes the active project here is set at null and it's crashing the shader. So I'm just going to add an if, and only if the active project is not equal to null, then I want to set my texture to like a texture that actually exists. And I believe that's going to solve the problem. And here it's not working. So I'm just going to add a console log and see if this is actually working, logging my active project and see, and here nothing is happening. So something is wrong. Okay, I understand why it's not working. Inside of my projects, I used on mouse over twice. So this is just like conflicting with each other. So what I need to do is just on mouse leave and that's gonna work. So yeah, now everything is working good. When I'm hovering, it's setting the project and this is good. And now all I have to do is check when the active project is equal to null, then I want to fade out the opacity. And now the way we fade out the opacity, unfortunately, it's not gonna be as easy as we usually do with like a motion tag and we're just gonna do like style, opacity. That's not gonna work because we're in 3D. And so the way that I'm gonna do this, since I need to manage it at the level of the shader, I'm gonna create another uniform. I'm gonna call it U opacity, have it like a value of 1, or let's do like 0.5 so we can see like the difference. And now that I have that, I can use it inside of my shader. And here I'm gonna use it inside of my fragment, not inside of my vertex. And I'm gonna have my uniform, U opacity, and it's a float value. And so now what I can do here to adjust the texture is here, the texture, instead of being a vector 4, I'm gonna have it a vector 3. And here I'm just gonna extract the RGB colors. And here I'm gonna do a vector 4. And I'm gonna manually do the alpha channel. And that alpha channel is gonna be equal to the opacity, right? I hope that makes sense. The last value, like it's RGBA, right? Alpha is the last values. And so I'm just overwriting that value with a U opacity instead of just taking the alpha from the texture. I hope that makes sense. So I'm gonna do that, save that, and see if that actually works. And as you can see, now my alpha is changing and this is looking really weird, but it's working. So that's good. And now all I have to do is find a way to animate that value. I'm gonna toggle it back to 1 and we're back at normal. And now I just need to animate that U opacity every time my active project is equal to null. So I can just add an else if, and here I'm gonna animate, right? So how can I animate that U opacity? Well, I'm gonna do the same thing here, mesh.current.uTexture, but I'm gonna be U opacity and I'm gonna do equal to 0. And here it's not else if, I'm just gonna do else like this. And I'm gonna set the value to 0. And if the active project is not equal to null, I'm gonna set the opacity to 1, something like that. And now if I hover out, boom, it disappears, hover in, it appears. So the interactivity is there. And I just need to animate that value. And how can I do that? Well, it's actually really nice. I'm gonna use Framer motion for that. I'm gonna create another motion value, and that's a way that we often don't use those motion values, but you're gonna see I'm gonna create an opacity that's gonna be equal to use motion value of 0. And then here what I'm gonna do is I'm gonna use the animate function, and that comes from Framer motion. And what I'm gonna animate is the opacity, and I'm gonna animate it towards 1. And then I can add the duration, maybe 0.2, and I can do on and here update. And this gives us a progress. And it's inside of that progress here that I'm gonna set that value. And that value here is gonna be equal to the progress. And I'm gonna do the same thing, but animate it towards 0. So here, I'm gonna animate the opacity towards 0, and this line doesn't change. And I'm gonna save that and see if that works. So at first, it's equal to 0. I'm gonna hover in, have something, hover out. And there's one last thing. If you have a good eye though, you can see that the color is getting a bit weird when I'm hovering out. And that's just a last property that we need to add, which is transparent true. And that basically allows us to modify the transparency, aka the opacity of the material. And with that, now that's a proper animation, right? It's a proper opacity animation without having like the weird color. So yeah, I mean, with that, we're basically done with the animation. We have something like this. It's looking pretty good. And yeah, this was a bit more complex than usual, but I think it's worth taking a look at some deeper and more complex animation if we want to have like really a unique look. So yeah, if you learned something, leave a like, subscribe, and I'll see you in the next one. Bye.